Swayam Prabha. Digital India. Educated India.
Now fulfilling customer orders. Okay, so before that let me, customer orders can be fulfilled only when we have required inventory. Typically we want the inventory to be non-negative, represent physical availability of the goods. That is orders not immediately fulfilled or lost forever. Like suppose you go to retail shop and you want to buy something, if it is not there you go to the next shop. It is very rarely you will say okay I will come tomorrow and find out, or we will wait for 2-3 days. Especially at a small retail shop setting or a time sensitive item, you do not need to wait for it. You go, if it is not there, that order is pretty much lost for the retailer. Okay. So we need to model this. Let us just take a look whether our inventory is actually going negative. I am not sure it's going to happen, but let us see. Inventory, yep, it is indeed. If you looked at the inventory graph in the previous setting, you can find the inventory was 40. Then when demand increased, even this simple setting, it went below 0 from time period probably 12 to 15. It is negative inventory. So this we don't want the inventory to go negative. So meaning if inventory is not there, that demand is lost. So ideally what we want is a straight line right here when inventory is not there. So what can we do? What can we do? We can create a new variable. So customer orders, let us keep it separate. We will update the sales rate as per that. And since we know the customer orders, we directly change the sales. We change your expected sales rate based on the customer orders and the expected sales rather than the sales rate. So let us update this also in our model. Then how should the equation of sales rate be? So what should be the equation of sales rate? Go ahead, let me do this. Customer orders, kg per day. Whatever equation we had for sales rate, we will just put it here. Step of 20,10. Let me delete this. Customer orders, the expected sales rate is now changes based on customer orders. So change in sales is basically expected sales rate actually represents the expected or forecasted demand. That is what it actually represents. Now how should the sales rate be if we should not allow negative inventory? Let us do the simple one, inventory and customer orders and sales rate, minimum of inventory and customer orders. Should that do the trick? Units won't match. First let me do both. We simulate it. Let us plot the inventory graph. It does not hit 0. Something has come in, truncated it right there. But if you do model units check, so many units errors, adjustment of intransitive etc. I have not given. So let me do that. Model units check. desired order rate. Okay. There will be units error for your minimum. Minimum we are comparing inventory and customer orders kg per day, but inventory is kg. So, it is going to show an error for that. So, how do you fix it? How do you fix it? Units error means model is not correct. So, either we have valid model and invalid model, not much in between. How do you fix it? I can't directly connect it, let us call it. What should the equation for this be? What will I connect it to? No. Inventory coverage is nothing to do with maximum you can sell. What is the maximum you can sell? Maximum you can sell is how much is inventory and how much you can actually. So, it is affected by the inventory, good. For inventory is in kg and I want max sales in kg per day. So, we need to introduce one more variable for time. Let us call it as minimum order processing delay. Let me connect. So, let us say max sales is inventory divided by minimum order processing delay, and let this be kg per day. Let the minimum order processing delay be 1 day, that whatever inventory I have I can dispose it in the same day, I do not have any issues in that. And sales rate, so instead of inventory let us call it max sales and customer order. Now, if I do units check I should not get any errors, all units are okay. So, simulate, I can get the actual inventory dynamics, or inventory does not go below 0. This is what we have right here. Right. So, now this model is very close. First we started with a simple model to start how to adjust inventory, then we try to include features in the model to better decision making, and then we try to include features in the model to make it a little more realistic to capture what is actually happening within the scenario. Like we do not want the inventory to go negative because we are assuming it is going to be lost, so that has to be captured explicitly. In case it was not lost and if there is backlog, then we need to create a separate backlog unit, we will do it later. And then we wanted to keep as less constants as possible, which can be directly computed. For example, we had a desired in transit inventory, but we got rid of it by using math. We had desired inventory, but since that is quite arbitrary, we decided to map it to how much inventory coverage is needed, which probably we can get more direct answer to rather than desired inventory. We substituted that. So, we have only very few constants to start with: supply delays, inventory coverage, and time to adjust inventories and in transit and customer orders, and model is kind of set for a particular echelon or the retailer. So, this is the model that we have right now, the complete retailer model. Start of the lecture, the first slide at least talked about supply chain. So, let us at least move towards the supply chain to see how it is going to look. Till now we have a model of the retailer. Let us suppose the distributor has the exact same decision structure as the retailer, meaning whatever distributor retailer is ordering, it actually is a order goes to the retailer, a distributor. Distributor will then check his inventory and supply that to the retailer, and in turn the distributor is going to order from say some factory upstream. Here the only retailer model, what is assumed is whatever is order rate, it is being provided by the distributor. There is no capacity on that. Now let us see if we are able to include a distributor model. So this order rate will actually go to the distributor, who will then check his inventory, and then based on that will provide the material to the retail. Okay. To do that, make a copy of your existing retailer model. Go ahead, or you can take a picture of it. First you have to copy it, and don't do all the steps, you just try to just read it once with me. Open that new file, set zoom to smaller size. Then pretty much what we are going to do is, instead of drawing the model again, we are just going to copy the entire structure and paste it. So that's, I am just going to select all, this is a big sentence, but all I am doing is select all, copy this. So let's go for that file, save as, let's call it RD1, view zoom 50%, it's too small. Because 75% is fine. So click somewhere in the white area first, then select all, copy. When you paste, unfortunately you will paste right on top of it. So without clicking mouse anywhere else, click on the black part, right here. You should be able to get this model. You got it? Please do it. So you will have one set of variables with a subscript 0, right? You have one set of variables on the right with subscript or a variable name with 0 in the end of it, another without the 0. So more times you copy paste, you are going to get 0, 1, 2, 3, 4, whatever, that's what Vincent does. Ideally we need to have proper names for each, but for now we will just go with this. We got the structure. So now if you simulate it will still run, all you have is two independent models built on the same screen, but still the dynamics will be completely independent, there is no relation. So first we need to capture that. For that, let us denote this part. I am just adding a comment right in the top here, saying this is your distributor and this is your retailer. So just for more convenience, so that you know whom I am referring to. So left side model is distributor for me and right side is a retailer. The one with subscript 0 is a retailer model. Okay. Now for the distributor customer orders is not independent, it actually comes from the retailer. So let us add a link arrow from desired order rate to customer orders. This is what he wants, so that is what he is going to order. Whatever he wants, he is going to order. So my customer order of distributor becomes equal to desired order rate. So I just added this link. Okay. Now I am to go ahead and delete this link. Okay. So desired order rate 0, customer order is equal to desired order rate 0. So that is all I did. Now based on this customer order, sales rate will happen based on the max sales that is possible, and whatever is sold is what is going to be dispatched. So this order rate is nothing but your dispatch rate. So now let us connect this sales rate with your order rate. This order rate is nothing but your sales rate. Only two links are here. nothing else changed. I am just saying whatever order came in, he just gave to distributor, and distributor has a decision structure to follow. And now sales rate, whatever is sold, it has to be passed on to the retailer. So as soon as it is shipped, so instead of sales rate, you can call it a shipment rate if you want, and this is your dispatch rate. So this shipment rate should be equal to this shipment rate. And instead of directly connecting them, I am just connecting them as co-flows, so that you can physically see retailer model and distributor model separately. Now let us simulate. You can check units, it should still match. Now once simulated, click on customer order 0, desired order rate and order rate. Just observe whatever I selected. Customer order rate is what the retailer end customer demand he faces, that is a step function. Desired order rate is what the retailer ordered to the distributor, and this order rate on the left top is what the distributor is going to order to his upstream player, could be a factory or a warehouse or someone else. So let us see the graph. Here you can nicely see that as there is a step change in the end customer demand, this desired order rate 0, that is the green line, increases, and since distributor is ordering based on that, you can see that the distributor's order rate is actually much higher and exhibiting much higher dynamics within the model. So this was one of the basic ideas we started Forrester to look at the dynamics as what he called as industrial dynamics, and came in his book. And nowadays we more popularly call this as the bullwhip effect, that we are seeing where any change in the end customer demand is getting amplified as we go higher upstream. Questions? Let's simulate your supply chain. So now imagine if you are adding more and more from this distributor, suppose there is another warehouse or there is a manufacturing and then there is another supplier, and imagine dynamics the supplier is going to see, because each player is only looking at the information he is presented with. The distributor does not have any idea about the end customer demand, he is only seeing what the order he is getting and he is reacting to that. The decision policy is the same, the delays are the same, it takes exactly the same delays. So for distributor also took 2 days to supply, for manufacturer, for the retail also is taking 2 days, both their time to adjust inventory is the same, both are using the same exact same forecasting policy. Even if they have exactly identical players, still we are seeing this dynamics that is unfolding because of change in demand, and just the sheer presence of these multiple stocks and units, which is further and further away from the end customer orders, which is right here. Any questions on this? So yeah, the only link we did was these two: customer order rate of distributor is the desired order rate 0 of retailer, order rate 0 of retailer determined by sales rate of distributor, and we just simulated and observed. It is a good modeling practice to give proper variable names and avoid all these subscripts. I just illustrated that model can be copied and you can do it. So you can think of appropriate names for the distributor echelon, and we call it shipment rates instead of sales rate, and call it supplier delay or something else.